Hello and welcome to episode 6 in the Delphi Training Series, brought to you by 3dbuzz.com. My name's Buzz.
And I'm Logan.
And before we get started, I'd like to take just a moment and point out that the high-res version of this video will be made available in the next few days. You'll be able to find a link to the high-res version on the youtube.com website, located to the right-hand side of this video. That is, if you are watching this video on the YouTube website. And if you're not, you can, go over to youtube.com/3dbuzz and find the link there. So anyways, we understand that the resolution is quite bad for viewing code that's being typed out. We understand that, but there's nothing we can do about it because YouTube only accepts videos that are encoded at low resolutions like the one you're viewing now. So again, give it a couple days, head back over to YouTube, and you'll find a link to the high-res version. Now, let's get started. What are we going to do in this episode? Well, finally, we're going to get to writing our MP3 player. Well, at least we're going to start it. The goal by the end of this particular video is to have a very simple MP3 player in place that will allow us to open up MP3 files, play those files, pause them, stop, rewind, and even track through them. So by the end, you'll have a pretty good working knowledge of working with MP3 files. Now, to get to that point, it's going to be an interesting journey because there's several things that we have to cover, things that will be new concepts to those of you out there that are complete beginners in the world of programming. So with that being said, let's go ahead and take a look at our objectives in this video. First and foremost, of course, create the simple MP3 player. In doing so, we're going to have to become familiar with external libraries, or as you may have seen them before on your computer, DLLs. And we're going to be looking at DLLs as they pertain to the Win32 world, not the .NET world, for any of you out there that just happen to know a little bit about .NET. Now, the things we're going to have to do, take a look at what DLLs are, why would we want to use a DLL, and we're even going to go as far as to write our own simple DLL, because as Logan said once upon a time, not in this video, by doing that it helps take the mystery out of what DLLs are. It really makes it a lot easier when working with them when you've done one yourself and you know what it's all about. From there, we're going to take a look at a third-party sound engine that has been created. It is called Bass. We mentioned that all the way back in episode 4 of the Delphi Training Series. We're going to show you where to get it. We're going to talk about licensing, how it's anywhere from free to costing a little bit of money, depending on what you plan to do with it. We're going to get it set up on our computer, and then we're going to use it to start writing our MP3 player with. And of course, the MP3 player is going to allow us to do the very simple functionality I named off just a minute ago. And then once that's done, we're going to take a look at the final GUI setup. As a matter of fact, Logan, if you don't mind, go ahead and open up the MP3 final. There we go. Just as a reminder, in case any of our viewers may have missed episode 4 in the Delphi Training Series, this is what we're going to be making. Real simple stuff for the most part, but a lot of concepts that you guys are going to have picked up by the time you get to the end. And it's going to take 2 or 3 videos to get to the end because we don't want to overload you, which is exactly what we would do if we tried to shove all of this into one multi-hour video. But anyways, this is the final goal, and in this video, it'll look like this at the end, but it's not going to have all of the functionality. It's just going to have the very simple stuff that I named a minute ago. So Logan, go ahead and close that out. I don't think we're going to need that anymore. Now, starting out, how do we play sounds? Because in essence, that's really what this project is all about. We want to introduce our viewers to working with sounds so that we can go back over to some game development and add sounds into our game, because obviously that changes the entire dynamic of a game when you're playing it when there's sounds. If you don't believe me, try playing a game and mute your sounds. It's boring. Well, a lot more boring anyways. Wouldn't you agree?
Boring or even frustrating. Sounds become a very critical cue in pretty much all modern games.
That's very true. So understanding how to work with these sounds becomes important. So how do we play sounds? Well, some people that are beginners might say, well, we simply talk to the sound card. No. We will not be talking to the sound card directly. Fortunately for us, there are external programs that are in place that we can talk to, and these programs will handle talking directly to the sound card. And these programs are known as, libraries. They are our DLLs. You guys may be familiar with drivers and things like that. And then that's what we're dealing with here. Now, this gets very complex quickly when we start talking about things like DirectX and then the driver itself and then the low-level hardware and all of the interaction back and forth between these different layers. And the goal of these beginner videos is to keep things as simple as possible. So please keep that in mind in case you happen to have a little bit of low-level knowledge and you're watching these videos. We don't want to overwhelm our complete beginners that are watching this. So when we go to have sounds played, we're not talking directly to our sound card. We're going to be talking to some sort of third-party library. Let's just get away from calling it a program. We're just going to call it a library. And that library is going to have a series of functions set up within it that we can talk to, and those functions will then take care of, accomplishing what it is we've asked it to do, be it output a particular sound file, rewind something, etc. Well, I say rewind. Hang on, I'm getting ahead of myself. Put that at the back of your head for just a moment. But the idea is we want to be able to control volume or output a particular audio stream or control what channel it's played on or if it's going to pan left or pan right or anything that you can imagine with sound. We're going to talk to a library, not to the card directly. Agreed, Logan?
Right, because some of the things you mentioned actually happen at different levels. Things like panning or tracking.
Right.
Tracking might be relevant only to a file you're playing,
right,
whereas panning could be relevant to all sounds.
Exactly.
So that's the other problem, is we have a lot of different levels and layers you were talking about.
And again, it gets really confusing.
If we use one concise library, that keeps things simple for us, because we just have one place we go for all of our sound needs.
Exactly. And again, if we really try to get in depth to how all of these different layers interact with one another, it can become quite confusing. But if this Delphi Training Series becomes really popular, I say we get into exploring stuff like that in the future, because it makes understanding what happens at a low level in a computer even more valuable. And it, of course, will make our programmers a lot more dangerous. So what libraries are we going to talk to? Well, we can use old school stuff, and we can talk with the MCI library. Nah, I don't think so. We can use DirectX, the whole DirectX suite, if you will, with Direct Show and Direct Sound.
So it's a modern method, but there's a lot of things you have to set up in order to use them.
It is. So we don't want to get quite that complex. So there happens to be several third-party sound engines out there that we can use. I call them sound engines. Again, they're libraries that contain all of the functionality within this library to handle all the sound manipulation we're looking to do, right?
Right. Like I was saying, one single place we can go for all of our sound functionality, not having to talk to different things for different functions.
Precisely. And in our case, we're going to introduce you guys to the base library. So I've been saying library over and over and over for the simple fact that I wanted to use that to tie around to the word DLL. You guys have seen them at one point or another in your computer days. A DLL file. The DLL stands for a dynamically linked library. And basically, as a matter of fact, you know what, Logan? It's time for whiteboard action. I think this will help make things as clear as possible. So we all know, we're in here and we're writing some code in Delphi, cute little thing. And we saw in episode 5 that we can take this little code block and we can put it in a function or a procedure, right? So let's just say that this is F open and close bracket. That's a function. Okay, it's going to return something back. And then we can write some more code. And we can package this up in a function or a procedure. Let's say this is a procedure and its name is just P. And we can go on writing all of these different functions and procedures. And the idea was to basically take a chunk of code and wrap it up inside a function or procedure. And that function or procedure is in charge of doing a particular task. As a matter of fact, in the sound world, you can think about you'd have some sort of function in our sound engine that we're going to be calling on that would be in charge of playing a file. You'd have another function that's job would be to stop the playing. Another function, pause the playing. Another function, maybe to set the position of where in the stream you're going to be playing so that you could say rewind or fast forward. Do you agree with this?
Right. All these different functions could very well have different things you'd have to do. For example, stop might have to rewind.
Right.
So you have stop and rewind, which is two different things you need to do.
Right.
But again, you can box those up into a function and then have that sitting as a simple module you can call.
Exactly. Now, up to this point, up to episode 5, we have covered functions and procedures now, and those have been embedded in our own programs. When we compile our program, we have a .exe file, an executable that we can then run inside of Windows, and our program executes. Well, now we're going to take a look at doing something a bit differently. What we're going to look at doing is compiling our program so that it is a DLL, which in essence is a program. It is compiled in machine language, so giving you guys some nice, amazing looking graphics. So let's just say that the name of this was x.dll. So now we have created a compiled file that's like a program, except the program can't stand on its own. It can't just be executed, right? Well, go ahead. You were going to say something?
What you've written there is just a function and a procedure. You've written no other code, no code that would run on load like a console app or on a button press like a VCL app.
Right.
Instead, this is all we're looking at right now is just a function and a procedure boxed up, and what would the result be?
So it's a file that contains multiple functions and procedures. And that's the whole idea, is that we're going to create a DLL that's going to contain various types of functionality. And the DirectX component suite, is a really good example how it contains like Direct 3D, Direct Sound, Direct Draw, etc. A whole bunch of different libraries within that suite, and the whole suite's just referred to as DirectX, that handle a lot of low-level stuff for you. It simplifies it. It gives you a high-level way of accomplishing things that need to be taken care of at a lower level, like playing sound out through a sound card, etc.
Right, and the way you could look at those different sounds or elements, you could look at a sound as an entire clip instead of having to feed raw data to a sound buffer.
Precisely. Now, the importance of a DLL, here's where we get to the really good stuff. Once a DLL has been compiled, so as we can see here, here's our x.dll file. It's sitting there as a file. Let me do another little drawing for you guys real quick. This right here, we're going to call memory. Oops, O-R-Y, with some horrible writing. And here is our XDLL that's sitting as a file. Here is our application up here. Let's just call it App1. Well, since App1 is going to be referencing function calls and procedures that are in the x.dll file, obviously those functions and procedures don't have to be all written out, all of the code for them in our application, meaning that our application now just got a little bit smaller, right?
Right. If you had written everything out, that would be duplicate code. The idea is to take some of that code, some of the reusable code out of App 1 and leave it in a contained, simplified place.
Exactly. So now, App 1, when Application 1 runs, depending on how it's going to talk to this dynamic linked library, what's going to eventually end up happening, though, is it's going to get loaded into memory. So in memory, here is x.dll. Now, once it's loaded, we can talk to it. We can send information to it, and we can get information back from it. The same way we can when in our own application, when we define functions and procedures, and we talk to those functions and procedures via function calls inside our application. It's just now we're doing it to an external DLL. But here's the beauty. I can now have a second program that was written. Let's say App 2. And App 2 can also rely on calls in here to x.dll. So hopefully at this point you guys can start to see, wow, yeah, you only had to write the code once all the way back over here in X. So we'll just go ahead and say xdll. It was only written once, but now multiple applications can access it at the same time. How cool is that? And what's even cooler is that the DLL is not loaded into memory multiple times. It's only loaded into memory one time, making it very memory efficient. Wouldn't you agree, Logan?
So right, for that, you only have one active version of that XDLL loaded, and you have all the apps that you want can tie into it.
Exactly. Now what's really convenient is the developer of x.dll can come out with a new version. And when the new version is released, you simply drop it in, you run your program, and all is good. You don't have to come back in here to App 1 or App 2 and recompile all of the applications that are going to use it. That's already done. I mean, they're just going to talk to this DLL. So once you get your new version of the DLL, you could just keep jamming along. Agreed?
Right. App1 and App2 can be left untouched as updates are made to the X.DLL. Like, let's say App1 and App2 are generally different in focus than X.DLL.
Mm-hmm.
It's an entirely different world. Like, let's say your apps are web servers and X.DLL is an image processor.
Okay.
The web server occasionally processes images, but you don't want to rebuild your entire web server every time the image processing part gets updated.
Exactly. Oh, that's a beautiful example. As a matter of fact, I can take that example and change it around to the sound world, since we're dealing with sound, right? We've got all of these different games out there that all use sound. Let me just say X, Y, and Z. So these are different games. Unreal, Quake, and Ridge Racer. I don't know, I'm making up some stuff. And here is this is going to be our sound DLL. All of these guys can talk to this, right? And what's really nice is basically it's standardized. So it's a standardized approach to handling all of your sounds when talking to a particular sound engine or a particular library in general, because you have to go about calling functions and dealing with the data that it sends back in a particular way. But once you've got that way established, or you know how to handle it, then every game you write, you just go about using the same way of handling sounds, right?
Right, and then that starts a foundation. That way you have an assumed standard between how you play sounds. And once you have that established, different games can play sounds on different sound cards without each game having to be updated for each sound card.
Ooh, that's a beautiful example. Exactly. Ooh, could you imagine what a nightmare it would be if, let's say we've got 5 different major sound cards available on the market today, and I'm going to write a game, but my game needs to make sure it has low-level control/access over each of those sound cards, because the way that the information's processed on each card is differently. Oh, what a complete nightmare. Isn't it much better to just deal directly with some sort of sound engine who's then going to talk over here perhaps to that particular sound card's driver, which is going to talk straight to... That's a sound card, ladies and gentlemen, I promise you. Does it look like a sound card to you, Logan?
Sure. It looks like one of those advanced ones that has all the co-processors on it.
There you go. And you can plug your little cables in back here, and there's your speakers, right? So, yay. All right, now I feel better. So anyways, you see we're really removed, a couple steps removed from having to deal directly with the sound card. And what's nice to us is when dealing with our sound routines, we've got a standard that we can follow with each game that we create, and we don't have to worry about, as Logan was just saying, different sound cards coming out or newer versions of a driver that may have been released. Right. And they've changed stuff.
You've got standards you can rely on, and if there are ever any bugs or problems with that sound driver, you can fix it at the sound driver level instead of having to go and patch every single game.
Exactly. Oh, what a nightmare that would be. So in our particular case, you can look at something very similar. We're going to end up with Base, and Base is going to be a library that's sitting out there. It's, of course, base.dll, and we can write, here's going to be our little MP3 player, and our MP3 player is going to be able to tell Base, we want you to play a particular file, we want to find out where in a particular file we're currently at, and it's going to send information back, and, well, we want to stop that file from playing, so we're going to send information. So we're communicating back and forth, right? But here's what's nice. Now we can turn around if we wanted to, and we can go back to our game Flee, and the same kind of stuff works. We want to create a stream. We want to start playing some music. We want to pause that music. We want to ask maybe what's playing or whatever. And later on, we're going to write some more complicated game. So we'll just call this comp for a complex game. And again, the same kind of communications is going to take place. So once you guys get familiar with working with Base, each time we go into writing some sort of new application, be it a game or business type application, if we're going to deal with sound, we already have an understanding of what Base is, how it works, and it's not a problem. Agreed?
Right. The idea is to not only make an MP3 player, but have the knowledge we need to add sound to anything we want from here on out.
Exactly. It's beautiful stuff. Beautiful stuff. So what we are going to do first is we are going to take the functions that we made in episode 5, and we're going to package those up into a DLL. So if I come in here right now and just clear everything, if you guys remember, as a matter of fact, let me look over here for our code so I can remember before we pull this up. We had some functions like 0, pad. We had get info. We had add numbers. Oops. So let's just, if I can get a D out, add, we'll just say nums. Let's see, what else did we had? Get between was a cool one. And we had get between. Now these were all defined. I can't spell. There we go. Get between. So these were all defined in our application that we made, a little console app in episode number 5 of the Delphi Training Series. But now what we want to do is we want to take these guys and we were going to package these in their own DLL. Okay, so it's going to become an external DLL, and then we're going to have our app, and our app is now going to be a whole lot smaller because it no longer has to have all of this stuff in it. We need to define it or prototype it out, which we'll see how to do that in a minute. But we don't have to put all of the code that exists in each of these in our application. They're all going to reside in this DLL. So then when we run our application, it's going to make the appropriate calls to the DLL, and the DLL is going to return information back. Make sense, Logan?
Right. It'll simplify things and make it so that the app only has to know about the functions and how to use them. It doesn't have to have the code. That code
that's right,
resides in the DLL instead of the app.
Exactly. Now, do you want to talk about... Yeah, I'll go ahead and talk about one last thing real quick. And that is when dealing with DLLs, there's two ways that DLLs can be loaded. We have implicit and we have explicit. So this right here is dynamic and this is static. What does that mean? Well, when you define a DLL as an implicit DLL, so it's static, that means the moment that our application runs, the DLL gets loaded into memory right there. And the DLL has to reside in memory all the way to the moment that our application is closed. And at that point, the DLL is unloaded. If we did an explicit DLL call, so in other words, we're dealing with the DLL in a dynamic approach, then what happens is it only gets loaded into memory when we need it. And we'll call it into existence in memory, and when we're done, we can unload it. Now this, of course, this approach gets a bit more advanced. We can see, though, real quickly where this would be a very cool approach if you're dealing with really large functions, a large DLL, etc., or maybe even something you're not going to use that often because it helps us better manage resources, better memory efficiency, etc. Does that make sense?
Well, a real-world example would be a program like Winamp. Winamp has various effect and output plugins.
Okay.
And you don't have to restart Winamp to load these plugins. You can go to the configuration panel and load and unload at will.
Exactly. Good example. So keep that in mind. Just wanted to point out that this is still a beginner video, so what we're going to do is all of our stuff is going to be implicit at the moment. And as a matter of fact, even when we get into writing the MP3 player, we're also going to be dealing with an implicit approach as well, where the base.dll file has to exist. If it doesn't exist, what happens is your program is going to die out on you when doing an implicit approach to handling DLLs or working with DLLs. If you try to do linking with a dynamic one, you can set it up so that if the DLL doesn't exist, your application will continue to run. So I wanted to point that out real fast. All right, Logan, let's jump over to Turbo Delphi real fast. And let's open up the functions that they created the other day.
So here's the functions project.
Okay, if you have not seen episode 5 in this training series and you don't know what the heck you're looking at, go and take a look at it. So anyways, there's the function getInfo, the function zeroPad, the function getBetween, and the function addNumbers. And if we scroll down a little bit further, we don't have any... Oh, yeah, there we do.
There's got a few examples.
And there's our actual program right there. Now, let's scroll all the way to the top of our console app here. What's the very first word we see?
That would be program.
Program. Now, in creating a DLL, instead of the word program being the first keyword that's going to appear, we're going to declare this application as a library. So what we're going to do here is we're going to change this over so that we have, instead of all of our functions existing in our own program, we want to put them in a DLL file. So let's go ahead and start doing that.
Okay. Well, I'm going to copy all of these out just so that I have them handy for the DLL, because the idea isn't that we rewrite all these by hand. The idea is to convert these over to a DLL.
Exactly.
So I'm going to copy all of these. not the examples, just the functions themselves. Then I'm done with this, so I'm going to close it out. I'm going to start a new project, and this new project is going to be a DLL wizard.
Now, that's kind of misleading. DLL wizard. It should have just been DLL in parentheses, something like template, because it's not a wizard that's going to walk you through a series of dialogue saying, is it going to be accessed by, is it going to be this, it's not going to do that. As a matter of fact, when Logan clicks OK, and blink, that's all it's going to do. It's just going to give you a template for the DLL. Now, key thing to point out right here is that first key word is the project's being declared as a library as opposed to a program, even though in the end it's still a program. It contains functionality. I just want you guys to make sure you understand that. If you start looking through Delphi help books or on the internet and all, you will see that DLLs are indeed referred to as programs. As a matter of fact, a DLL, a dynamically linked library, doesn't have to have a DLL extension. It can be an EXE, it can be a driver extension, a font extension, etc. But DLL is, well, obviously quite common. So it's going to start out with library. We're going to put our functions in it, but then we've got one key thing. As a matter of fact, if I can get you real quick, Logan, to jump on down right before the begin end, and let's go ahead and hit enter a couple of times and write the word exports. Here's the key thing when writing a DLL. Any kind of functions that we want to share with the outside world, meaning that another application that's written and is designed to link to this DLL during runtime, any functions that it's going to be able to access have to be exported out right here. So leave the export section there. We'll put those in just a minute and go a line above it, and let's go ahead and paste the code you got. This will make more sense in just a second, but it's very important I point out. Okay, so Logan has just simply pasted in all of the functions that he cut out of the other application or copied out of the other application a second ago. So now, watch this. First thing I want to do is let's go down to exports real fast. And under exports, let's put add numbers, because that was the name of the first function. Put a U in there.
Numbers.
Okay, a comma. Next line, we can do it all in the same, but we'll just do this on separate lines. Get info, because that was another function we had. Next line, 0 pad. Notice how each of these functions are separated with a comma. And the next one, get between. Very, very nice. Now, next thing I'd like to point out, notice how Logan has put a terminator at the end, and that designates the end of our export section. This is critical. If you do not do this, it will not work. Now the next thing that we need to do is we need to go up to each of our functions, and after the function's return type, in this particular case, we're returning an integer, we need to add another thing, and that is std call, standard call. Now, got to be real careful with this one because a deeper understanding of parameter passing is kind of required. Remember how we talked about where's the mouse at? Here we go. Remember how when we talked about when we call these procedures, we can pass parameters to them and we can return information back? Well, at a low level, that's being handled in a very particular way. The way that information's laid out in memory, I'll just say that, when it's passed to it. Now, right now, if we were writing this DLL to only be used with Delphi applications, it would never be used by an application written in another language like C or C++, we would not have to use a standard call. We could simply leave that out, and this thing is ready to rock and roll. But it is just a good habit to get into putting standard call in there, because what standard call is going to allow us to do is write a DLL that could then be accessed not only by programs that were written in Delphi, but also if somebody else came in and wrote a program in C++, they could also access your functions without any problems. Does that make sense?
That's the whole idea of a DLL, is it's to make code available to any Win32 application. Not just a Delphi app or not just an app written in C, but a general Win32 program.
Precisely.
And then that standard call lets us specify that, yes, we want this to be handled, all the parameters to be handled in a general, standardized way so that any Win32 program will be able to access it.
Exactly. So let's go ahead and add standard call to the end of all of our functions.
All right, get info, check. 0 pad, check. And get between. Check.
Okay, good deal. That's it. But real challenging stuff, eh, guys? I mean, that's all there is to it. Let's go ahead and save this project out now.
So I'll hit Control-Shift-S, and I'm going to make a folder for this. We'll call it DLL example.
Okay.
And the project itself could just be called DLL example as well.
That works. So this file would actually exist as a matter of fact, you have one of these folders open at the bottom that goes into our projects. So go into DLL example. All right, so right now, if you take a look in there, we only have our project, our DPR, and a couple of other files. Let's go ahead and compile it now.
Oh, right off the bat, look at this. Under the project group, it's showing it as a DLL file.
Very nice.
So if I compile, I'm going to use the shortcut Control F9.
Okay. Now, no errors. Everything looks fantastic. Let's open that folder back up. Ooh, check it out. We now have a DLL file that exists inside of this folder. Now what we need to do is create an application that will link up at runtime and use the functions within the DLL file.
Okay. Well, let's...
In doing this, let's approach it a little bit differently. Everybody's used to, at this point, coming up file, closing down the whole project and starting a new project. Let's work on two projects at the same time, which is one of the things that the IDE gives you. So it's a very nice feature. So we can actually have a new project, have two different projects inside a project group, if you will. Sound good to you?
Yeah. That way we don't have to go back and forth and keep opening and closing every time we want to jump between two projects. So we can go to the Project Explorer and use some of its abilities. What we want to do is make it so that we have two projects available at the same time. Now, we only have one project, and we need to create another one.
Mm-hmm.
So we can use the new button over here as opposed to on the main IDE itself, and that will let us create a new project group without closing or removing this one.
Nice.
So I'll say new, and we're going to keep this simple, just a console application.
Okay.
So here's our new app. I'll go ahead and get this saved out right off the bat, so I'll hit Control-Shift-S. And this should, we'll save it under the DLL example.
Okay.
And we'll call this Use DLL example.
Okay.
Save that. And because I hit Control-Shift-S for Save All, it's also wanting to save the program or project group itself, which is awesome, because then when we close Delphi because we're done, and the next day rolls around and we go to open Turbo Delphi back up, we can now simply open up this project group, and it'll open up all projects within the group. That's very nice. So for the project group, I'm going to call it DLL project. As well. Yeah.
A DLL project.
Oh, project? Okay.
Yeah. There we go. I like it. Okay, so we'll save that out. That way all of our names are different. So now that we've got this going on, now we're in a regular console type application that we've been writing over the last couple of, what's the word I'm looking for? Episodes, yeah, that's it. Now, what do we need to do in here? Because we need to be able to link up with, at runtime, our DLL. Well, it's really simple. All we need to do is define our functions. Let's go ahead and define them here, Logan. But then after we define and show them working, then what I'd like to do is add a separate pass file and treat it kind of like a header file.
Okay.
Does that make sense?
Yeah.
That means when they see base, they're going to be totally in tune with what's going on.
Yeah, I see where you're going with this.
So we'll start out with, basically we need to go ahead and if you want to just copy and paste each of our functions from over here. So we'll jump back to here. What I like to do is just, it doesn't matter, just copy and paste each one over.
So this is jumping just under
just right up under the uses, and we'll just paste them in. And then we'll just jump back over to example, grab the next one. So your program must be aware of these functions or procedures. It must know what kind of parameters it takes. It must know the names, etc. So Logan's just copying each of these out and putting them there. Now, we can look at this. That's all of it. So let's go back over to our app. Okay. So this is kind of like prototyping. We're prototyping out what all of the functions are going to look like. But at this point, our application is going to say, yeah, that's nice and everything, but where? So we need to, after standard call, we need to add a little bit more information. Put external, because we're referring to an external DLL, and that's a keyword, space, open single quote, and then DLL example.dll. There we go. And then we need to have that piece of information at the end of each of those functions.
So this is just telling it, like you said, exactly where this function is located. We're telling that it's located externally in the file DLL example.dll.
Right. And what's really cool here, let me just point out, is that as long as that DLL exists somewhere within your environmental system path, it'll run just fine. Meaning that, what we're going to do is we're going to keep our DLL with our executable. And we're going to do the same thing with base as well. When we write our MP3 player, the base.dll file will always reside with our MP3 players.exe file. But we could move this over to the Windows folder. We can move it over to the system folder. We could create a new folder and then add that into our system path, and and move the DLL there, and it will also work just fine. So I just wanted to point that out real quick. Okay, so now that we've got these all defined, I want to go ahead and compile it real quick.
Okay, so Control F9, and it compiles.
And no problems whatsoever. So the next thing we need to do is let's see if we can use it. So if you want to start out with, maybe go up to var, to right before begin, and let's put a var section.
Yeah.
And make a variable called total and a type integer. So here comes our first big test. Now under begin.
Just to keep things consistent, I want to make this lowercase total just like VTM5.
That works. Now, say total colon equals. All right, guys, you ready for this? Watch this. Add numbers. We call it just like we did in 5. And send it a 1. Or just send it 2 numbers. Doesn't matter. Something, comma, something. And boom. Done. It's that simple. Compile that, as a matter of fact. And let's see, what do we have? Value assigned to total is never used. So it's just kind of griping that we never use total to do anything with. So let's go ahead and jump down and write something like the result was, and then send it total. And then let's go ahead and do a read line just to pause things for us, and let's compile. And take the plus out. And put a space in there. Or a comma is what I was looking for, sorry. Getting carried away. There we go. And let's go and compile and run. And the result was 15. Beautiful stuff. So check it out. We don't have the add numbers function anywhere. Go ahead and hit enter for me real quick. We don't have it anywhere in here. We don't have the code for it. We have the code for it over here in a whole different other file, all the way back up here, function add numbers. There's the meat of it right there, the body of code that resides within the function. Take in or send back whatever we brought in plus the other number we brought in. So there, we're actually using our application to link up with another application, a DLL file, and use a function within that DLL file. As a matter of fact, make this even more interesting. Here's our example. So we can go ahead and come in here and run it. Hit enter for me. Check this out. Let's go ahead, jump over to the folder where that exists, and delete out that DLL. So Logan is deleting the DLL file. Now go back over and execute that again. We have a problem, don't we? We can't run it because it doesn't have a DLL file anywhere. The DLL file went bye-bye. Yeah, and if he tries to run it from here, the application has failed to start because DLL example.dll was not found. So, I love that. That's good old Windows for you. Just, reinstall it and maybe it'll work. So go ahead and click OK. And all we need to do now is jump back over here to Turbo Delphi, and we'll just simply compile the DLL. We can just right-click on it right there.
Yeah, we can right-click and compile. Let me just point out one thing about working with multiple projects in the Project Explorer.
Okay.
In order to switch over to one to make it the default, because I like using the Control F9 shortcut a lot. It's handy.
And whichever one's bold is going to be the one that's going to compile.
You notice we've been using that, and we've been compiling the executable. If I wanted to switch back to the DLL, I could double-click on it. And now when I use the Control F9 shortcut, I'm compiling DLL example as opposed to the executable.
Exactly. Now jump back in. There's the DLL. Now run the application. And it works. Very cool. So go ahead and take just a second and prove that a couple more of those lines work. Do the write in and call on get between.
Let's see, get between, and we'll give it some kind of config
resolution equals 543. There we go. It's a weird resolution.
And then we're saying that this double quote is the start marker. Another double quote would be the end marker, and we'll end off the get between, we'll end off the right line and terminate it.
Beautiful. So let's see what that gives us when we execute this.
Now, you notice what I did. I just compiled, and I have the DLL selected. If I attempted to run, I would say that we can't run because there's no host application. Again, we're working on the DLL. To run this, we need to switch over by double-clicking. Then we can compile and run the executable.
Look at that. So now we've got 543 being echoed out in our console because 543 is what was between our two markers. Hey, it looks like we're able to access these just fine. Do a final one. Just do get info. That's quick and easy. We don't have to send it any information. And let's compile and run. And it's Monday, November 6, 2006 at 5:20 p.m. Fantastic. All right, go ahead and close that. So, ladies and gentlemen, we have, let me grab my little pen right here and jump back over here to our whiteboard. We have created an DLL file. Then we have created an application. And at runtime, the application is sending information and making calls over to our DLL, and the DLL is sending things such as the result, the date, time, etc. back to our application, and we are using it. And we have been using the implicit approach to dynamic linking, and we know that as a fact because Logan demonstrated that if the DLL file was deleted, we simply could not run the application at all. If we had done a dynamic approach, the explicit way, then we could have still run the application. We could have done some nice things in regards to telling people that that particular module wasn't found, or who knows. Anyways, that's the whole point. So this is going to bring us up to the final thing that I'd like for Logan to show you guys, and that is when working with other people's DLLs in the industry, third-party DLLs made by companies or other individuals, you're going to hear the word header file a lot, aren't you, Logan?
Oh, yeah, a whole lot. Anytime you need to get into anyone else's libraries, data types, anything. So, and a header file, sounds all fancy, isn't really anything fancy. It is. You guys have already looked at it. It just wasn't a header file. It was just headers, if you will. Where's my mouse at? There it is. So we'll come back over here. See this stuff right here? That's pretty much what we need, right, Logan? Right. Those, you could say that those are the headers for those functions.
You hear that, guys? Say that one more time, Logan.
The headers for the functions that we use.
These are the headers for the functions we're going to use in the external DLL. If you don't mind real quick, just so that this is going to be completely in sync with our MP3 project when it uses base, go ahead and set up a header file.
Okay. And the idea with this being a header file instead of just headers is that it's just at a separate file. In our case, that means a separate unit.
Okay.
Since it's a separate unit, that means we could go and say new unit. And within this, we could take these header or function headers out of the program, place them into the unit under the interface section, and save the unit out. Let's see. What do we want to call this?
DLL headers.
Yeah.
I mean, that works. Obviously, when we start working with base will have it. And you guys may have noticed, if you can pull up the folder where that project is, it's a pass file that just got saved out. So when we start working with base, we're going to have, like in this particular case right here, we have DLL That's what we call our DLL file. And we've got DLL headers.pass.
Yeah, I thought it was something to make a little bit more concise and flow. I'm going to rename this and call it DLL example.
Agreed. Because I was just about to say that as well. There you go. And so that's the header files for the DLL example. And so when we get over to working with base, you're going to see we have a base.dll and we have a base.pass file. And inside the base.pass file is all of our prototypes, all of our function declarations and all.
So I guess the last piece of the puzzle then is how do we use this within the app? Because right now I've taken all these out. So if you
compile it, yeah, go ahead.
If I compile it, it is okay. I see what it did. It took the unit and added it for me. If I take that out and put it back to the way it was, like let's say we had written the app without knowing about DLL example.
Right.
Now we want to use something like add numbers and we try to run it.
There's errors.
No, it has no idea what add numbers is. So that means we can go up to the uses section and add DLL example. Tell it that, okay, we're using DLL example. Well, that's good. You have add numbers inside of DLL example.
So now you can run it real quick. And there it is, all working beautifully. So that is what we are about to see. I mean, this is it when we start working with base. So with that, Logan, I guess the next thing we need to do is start talking about base. So if you don't mind, let's go ahead and pull up the Unforeseen website real quick. Is there anything else you want to add about DLLs?
No, I think that sums it up nicely. It's in the end, we have everything set up so that our main app is kept clean. You see, we don't even have the headers to the functions themselves. All we're looking at inside of an application is, we're using DLL example. That makes things like add numbers and get info available.
Exactly. Very cool. Okay, so over to unforeseen. So straight from the unforeseen website, what is bass? I mean, I've already talked about it a couple of times in regards to this is going to be a third-party sound engine that has been created that we can freely use for writing sound abilities into our applications. From their website, they've got the following. Bass is an audio library for use in Windows and Mac OS X software. Its purpose is to provide developers with the most powerful and efficient, yet easy to use, sample, stream, mod music, MO3, and recording functions. That's right, ladies and gentlemen. You get all of this amazing stuff. And they want to do it all in a tiny DLL. As a matter of fact, under 100K. So on Windows, Bass requires DirectX 3 or above for output and takes advantage of Direct Sound and Direct Sound 3D hardware accelerated drivers when available. On OS X, Bass uses Core Audio for output, and OS X 10.3 or above is recommended. Both Power RC and Intel Macs are supported. The Power RC,
Power PC.
I was about to say they must have had a typo if I did a copy and paste. So the Power PC and Intel Macs are supported. Now, here's the next beautiful thing about us showing you guys where to get and how to use this sound engine. C, C++, Delphi, Visual Basic, and MSAM APIs are all provided. So that means you learn how to work with Bass and Delphi and you decide to do some VB programming, you can use Bass with Visual Basic. If you decide to get into C++, you can use Bass with C++. They've provided all of this for you. That's fantastic. Now, the next thing that should come to mind as you're sitting there thinking, wow, that's awesome. I got all these great capabilities right there in this library file. How much does it cost? Well, if you are developing non-commercial products, in other words, you develop this MP3 player and you want to give it to everyone you know, and you're not going to charge for it, Bass is free. That's how their license works. Free for non-commercial products. If you are an individual making and selling your own software, then the shareware license is for you. So again, an individual, and then that only costs €100. Again, that's straight from out of their licensing file. If you're a company and you're creating a single commercial application, for a single commercial license, it's €950. And for if you want to just do a one-time payment and you want to use it as many times as you can possibly imagine, an unlimited commercial license is €2,450, which is still a really good deal if you think about it. So, because there's some amazing abilities in Bass. Amazing, guys. It goes way beyond just playing sounds. So anyways, that is a look at Bass in regards to a high level. Now let's go ahead and look at it at a lower level. Let's go ahead and show them where we can download it from.
Okay, and that would probably just be under Bass itself. Yeah, there's our download link for Windows or for Mac. Okay,
now we have already downloaded the file, correct?
Right.
Oh, look at that too, man. Click back over there. Let's see. Main features, samples. It supports WAV, AIFF, MP3, MP2s, MP1s, OGG, and custom-generated samples, sample streams, file streams, including MP3, etc., internet file streaming, custom file streaming, multi-channel. Scroll down a little bit. This is awesome stuff to look at. So multi-channel streaming, MO3 music, mod music, multiple outputs, recording capabilities, decoding without playback, speaker assignment, high-precision synchronization, custom DSP. So if you want to do your own effects, DirectX 8 effects, 32-bit floating point decoding and processing, 3D sound. Guys, this is amazing. That is a lot of abilities right there at our fingertips. All right, so Logan just showed you where you would go about downloading it from. Okay, right there. So we have already downloaded it. So there it is, base23.zip file. So we need to go ahead and get this set up. So let's open that guy up and take a look at what's inside.
So we've got a C folder, Delphi folder, VB folder, and the Bass DLL itself.
And a help file.
So yeah, there's
the help file. Okay, so let's go ahead and show them how to install this.
I'm going to take this entire zip file and extract it right here underneath Setup.
Okay.
Now, the first thing we need to do is we need to set it up so that we can use base within our application. And this is going to work almost exactly as the way we have seen in our DLL example.
Okay.
There's two things we need to worry about. We have a base DLL file, of course, and we have a base unit that we will use inside our program to expose the functions available within base.
Our header
Their
file.
header file of sorts.
Okay.
So, we need to go into...
I'll help you out here. Let's just jump over into Turbo Delphi and start our application. Sound good to you? Because then we can just copy and paste our stuff over.
Okay, yeah, that works.
So we
we're
can
done
just
with
close
this.
all this stuff out.
Yeah, I'll keep a safe copy.
Okay, so close all. And we're going to go ahead and do a new, now we're going to be doing, instead of a console app, we're going to do a VCL Forms application, because it's going to be a Windows-based thing. All right, very good. And now we can go ahead and save this project out and make a new folder for the project. It's MP3 V1 or, no.
Just MP3.
Yeah, MP3, because we're just going to keep adding to this.
This will be our main unit for the main window.
Okay.
And the project...
MP3 player?
Sure.
Cool. All right. So now you've got it compiled and everything. So now what we need to do is we'll need to put the DLL file that we just got in that extracted area. Yep. Copy that and come over here. Go into
there's our MP3.
And paste it. Excellent. And now the next thing we're going to need to do is take that pass file, and it's going to need to be added to where we keep all of our library files, if you will.
So if we look under the Delphi folder, they have a bunch of examples, and then they have the main base header unit. So if I copy that, I can jump over to where I have Delphi installed, which is C Borland. If I jump in a few folders, we have our lib folder. If I paste that in here, this is, of course, linked up in our library path. That makes sense. The main lib folder would be linked within Turbo Delphi. So if we drop this unit in place, that means any program we compile will have access to this unit.
That's right.
Or rather, we can go into any program and add base to our uses section.
Now, we've talked about this in previous previous episodes of the Delphi Training Series. If you guys want to keep things all structured and organized, you can, of course, create a base folder, dump this into the base folder, but then you just need to go into your options and make sure you add that folder into your library path. Just wanted to point that out.
Right.
Okay, so now with that out of the way, it's set up. How simple is that? So now what we need to do is we need to initialize it. Let's see that the DLL is indeed working.
Okay. So we'll jump into our app and
actually, I hate to do this. I apologize to both you, Logan, and our viewers. Let's first open up the help file. I want to point out two things. I want to keep the help file handy.
Okay, here's the main.
All right, now go back to the base 2.3 folder right behind you. Okay, let's jump back into Delphi real quick, just before we're done talking about this. Logan kind of skimmed over it a second ago, but take a look at all those folders there. They have provided a lot of fantastic examples, guys. So if you find this stuff really cool and you'd like to create applications that work with sound in a far more complex way than we're doing here, feel free to go in here and load up some of these different examples that they've provided and take a look at how they go about accessing the DLL.
Okay, because they have a lot of examples that'll use some of the more advanced functions and some of the things we simply don't touch on because there's capabilities far beyond what we're going to use. All we're doing is loading a song and playing it in an MP3 player.
Okay, so now you can go ahead and get rid of that folder. All right, now back in the help. So what we want to do is initialize it. Help, ladies and gentlemen, is one of the most important things in the world. That's right. You're going to find everything you need to know inside this help file. So make sure you use it. We're going to use it throughout this application development. Every time we do a function call, we're going to jump into the help so that you guys can see what kind of parameters are being expected by that function, right?
Right, and that way you can see exactly why we're typing what we're typing.
Exactly. So we need to initialize base, as we were just about to do. So how would we use help to figure out how to initialize base?
Well, that's what you just said, initialization or initializing base. Well, there's an initialization section within the help file.
Aha.
So we can expand that, and then there's a bunch of functions. One of them is simply base init.
Mm-hmm.
So let's take a look at that.
Okay.
Now, this base init takes in quite a few parameters, more than you might think.
Ooh, as a matter of fact, if you don't mind me cutting you off, boy, I'm awful about that tonight. not only the parameter thing, let's first talk about what they're looking at. Again, dealing with a brand new programmer who's just gone through our episodes 1, 2, 3, 4, 5, and they have a little bit of an understanding now in regards to functions, procedures, and variables / parameters. What are they looking at here? Well, it kind of looks like a function in a way, but it kind of doesn't. What you're looking at right here is the prototype, if you will, of a function in C or C++, correct?
That's right. And throughout their help file, all of the code examples inside the help file itself are presented in C. That's
right. You guys are used to seeing the return type of a function at the end, but when over in C or C++, it's actually at the beginning. So right here, this is going to be a function that's going to return a Boolean, a true or a false, or a 1 or a 0. And then the function's name, and then our open parenthesis, and our parameters that you guys were introduced to back in the last episode. So we're sending in an int. What's an int? Well, it's an integer. Okay, so these are C variable types, dword, a handle, etc. Right? So just wanted to point that out. Just follow along. It really is the same thing, just written in another language.
Yeah, precisely. So this tells us what we need to do to initialize base. Now we need to translate this into the world of Delphi so we can get this running within our application.
Exactly.
So I'm going to switch back to Delphi, and I'm going to switch over to code. Now, before we can start using this, if I were to just start to type out base init, that's not going to exist. We haven't told it where to get base from.
Okay.
But if you remember a minute ago, we did paste the base unit into our lib folder, which means we should be able to use it here under the uses, like such.
All right, good deal.
So now we can initialize base because we should have access to that base init function.
And the question will be, where would you want to initialize it at? Since we're doing a VCL Forms application, where at?
Well, it would make sense to initialize audio as soon as the app loads, because the goal of this app is to be an MP3 player. Its only purpose is to play audio.
That's right.
So we can go ahead and initialize right off the bat as soon as the app loads.
Okay.
And I'm going to do that within the Forms on our create event.
Okay.
Or I could have gotten to that more quickly by just double-clicking on it.
Yeah.
So here's our form create that has been set up for us. So inside of here we can say base underscore init, open parenthesis, and you see the tooltip that pops up to show us a lot of things. All of those match what we had just seen in the help file.
That means the adding in that base in the uses section is working now.
Right, because if we didn't have base up in the uses, Delphi would have absolutely no idea what base init is. So
right.
it would just give us an error when we compiled and give us nothing when we tried to do an open parenthesis.
Precisely.
So now we need to fill this in and get it working. The first thing that base init is expecting is a device. What is a device in this case? Well, that can be looked at as an audio device within Windows, or more simply, a sound card.
All right, let's jump back and forth between help and this as we're showing them these.
Okay. Now, like I was saying, with an audio-based program, it's possible to select different sound cards for output. If you really wanted to, you could dig in there and find, like if you had two separate sound cards on a computer, select one of them over the other.
Okay.
Now, this is just a player. This isn't really a big sound development environment.
Right.
So a player would just want to use whatever the user happens to be using. That would be the default device in Windows. And if we look under the parameters section for base init, the device will allow us to specify -1, and that tells it to use the default device.
Which is perfect.
So that way we don't have to go looking around or listing devices to decide on one, and we can tell it to use whatever has been selected as default within Windows.
Okay, cool.
So there's our first parameter, -1.
Wow, that was simple.
Next parameter. And the next parameter in the list is the frequency.
Okay.
The frequency is simply described as the output sample rate. You may have seen sample rate by looking at things like CD audio, and how CD audio is 44 kilohertz versus older audio samples, which might be 22 kilohertz, or DVDs, which might be 48 kilohertz.
Sure.
Now, I like to stick with 44 kilohertz simply because that's the native sample rate, if you will, of a lot of existing audio files. A lot of MP3 files are 44.1 kilohertz as a standard.
Now, this doesn't mean that we can only take in 44 kilohertz.
No, this is the other side. This is the output side of things.
Meaning that if it was like 22K, it would actually be upsampled.
Right. So the key here on this output is what can the sound card in question handle, not what the input file is.
Okay.
So you don't want to go specifying like 98 kilohertz on an old sound card.
Right.
But, I mean, 44.1 kilohertz has been a standard for quite a while, so that's what I'm going to specify. The only thing to keep in mind is it's not specified as a float, so I can't do something like 44.1. This is specified as, I don't remember, it was a D word, so
it was a D word.
Basically an integer, and it's specified in hertz, not in kilohertz. So if I was to write that out, it would be 44,100 hertz.
Okay.
So that's our output rate. The following parameter is flags, and there are a lot of different flags which act kind of sort of like options in how we want this output to work. For example, telling it that it's going to be mono instead of stereo and so on. Now, I'm not going to set up any of these, so I'm going to leave this option 0, because you can see, even though we're looking at words here instead of numbers, this is still defined as a D word, so basically an integer.
Okay.
And we're not going to get into flag combining just yet.
Right.
So it's taking in a number. I'm going to specify 0 for no flags.
Okay.
After that, we get into, it's expecting a handle for the window.
Ooh, a handle for the window. How about a real quick discussion about handles?
Sounds good.
All right, so in order to pull that off, let me move this mouse over here and come down here and grab the whiteboard, because we always need a whiteboard. A handle it's just a reference. It's a reference to a system object. It can refer to a window, a control, a menu item, a memory block, a file, almost any other kind of entity that's used by the system. And it's when we start getting deeper and deeper into Windows programming, which is one of the things I would very much like for us to explore, Logan, as we get deeper and deeper into these episodes, you're going to find that there's going to be a lot of calls and callbacks and things like that when you start talking with the system or different libraries, that you're going to pass something off and then it's going to get back in touch with you later on. And it needs to know how to get back in touch with you. And that is one of the things that you're going to find yourself working with often, and that is handles. And while you haven't seen them, they've been completely transparent to you. They have existed up to this point. Every time you create a window, that window has a handle to it. So what ends up happening is basically just, again, a real simplified method. You end up over in memory, if you will, with a whole bunch of handles. So let's just say that this is handle 1, this is handle 2, handle 3, and these handles are simply pointing to different things in case we need to, well, gain access to it. So this could be our window for our application we're using. This could be a handle to a file that we may be working with at the moment. We may have opened up a file and we're reading from it or something. They're just handles to system objects. That's the easiest way to explain it.
Right, and they're used so that you can communicate with different functions or even different systems.
Right.
And make that function or system aware of some object that you want to send it.
Exactly.
You want to make some function aware of that window.
Exactly.
So you tell it about the handle. It can take in that handle and look up that window.
Right, and we're going to be working with handles more and more often as our applications become more and more complex. As long as you remember, it's just a reference. We're going to store it in a variable, right? And then we just call upon that variable so that we can point to there's that particular object. No different than if you, all right, analogy for the real world. Here we go. You go to the airport. You're standing in front of a luggage carousel, and you're watching how the luggage goes around, and there's a particular piece of luggage that you want to communicate with. You want to grab it. You're going to grab it by the handle. That's how we pick it up. So handles will become very important, again, for referencing particular objects. So in this particular case, if we jump back over into I guess the help file for starters. It is wanting a handle, and you'll notice it says handle when. It wants to know us, the application that's initializing this.
That's right.
The window.
So we need to get our Delphi equivalent of that. So I'm going to jump back into Turbo Delphi. Now we have available to us a property from application. Because this is a form, we have an object we can access called application for the overall application. You saw that when we grabbed the path, when we were getting the executable path or exe path. Right. Another thing we can use is handle. So we could do, this is written out a little bit longer than it needs to be, but you could say application dot handle. Or more simply, just handle, because we don't have to reach into that. Right. So I'm going to shorten that down to simply handle. I just explained.
So now base gets initialized, and it knows what window just initialized it.
Exactly.
That's simple.
Okay. So that takes care of our handle parameter. Now what's left? This class ID. If we scroll all the way down to the bottom, we can see that is the class identifier that will be used to initialize direct sound. Because like you were saying, this the base library utilizes DirectX.
Mm-hmm.
So if we want, we can control what class identifier it uses, or we can use null to have it just use a default.
That'll work.
So
it says null, but again,
we're in Delphi, so that's going to be nil.
That's right. This, really thinking about this, Logan, this is an awesome example of how a DLL can be written in another language. In this particular case, was written in C or C++. Yet here we are in the wonderful world of Delphi, and we're accessing that stuff. I mean, if you pull that help file back up again, everything looks slightly foreign to those that are only becoming familiar with Delphi, because everything right here that you're looking at is in the world of C. But we're accessing it through Delphi, but remember we had that header file, that base.pass file that declared all of these things for us. As a matter of fact, Logan, if you could find that base init file in the pass file real quick.
The declaration of base init?
Yeah.
Sure, we could go up to here. I can control left click on base, and that'll jump into the unit itself.
Mm-hmm.
Now if I scroll down closer to the bottom, we have all the functions that it references. Here they've got a constant for what file it is, base DLL. After all these functions, we have external, just like we use.
Wow, it looked just like what we had going on a minute ago. As a matter of fact, if I can, see if you can find it real quick. Oh, beautiful. So there's base init in this line right here. And look at this. Taking in a device, integer. It's taking in frequency and flags, it's a D word. It's taking in window, its type is a handle. And then the class ID of type PGUID, and then look at this, there's bool at the end, a standard call to external base DLL, and base DLL is just a special kind of variable, a constant, so meaning it's not going to really be variable, it's just always going to stay that way. That contains base.dll in it. So anyways, what I was just saying was, back over here in the help file, all this stuff has been written in C, but we're able to prototype it out in the Delphi world so that we know how to talk to it and we can access it.
So if you do manage to get something confused between the translation from C to Delphi, you can always load the base unit itself up because all those functions have to be defined within it.
They have to, and they have to be defined in the Delphi way when we're talking about the base.pas file.
So if something is written in C and just doesn't work over in Delphi, you can always take a look at this file and see how it was defined.
Exactly. Okay, I just thought I would take a quick little sidestep there and mention that.
Okay, so back to the base init.
So let's put a terminator at the end of that. Okay, now it's going to return something back to us. It's going to let us know, did it or did it not initialize? And there's that bool right there. So we need to find out, did it or did it not work?
So that means we need to put the entire thing into an if statement so we can check the result. So I could say if base init is equal to false, then it failed to initialize audio at some point. So we can alert the user to that with a show message. Just say something like audio initialization failed. I see it.
Okay.
Like so. And I guess now we can try compiling
just go ahead and run it. And there's our window. Now, if something would have, gone wrong and base was not capable of being initialized, we would have instead got the message, audio initialization failed. And if the DLL file could not have been found, check this out. Go ahead and close that out. What happens if we delete or rename that DLL back over there?
All right, so back to our MP3 project folder. I can just rename it since it's looking specifically for base.dll. If I try to run it now, running from Delphi is just going to look like nothing happens. If I run it from Windows, then we get the good old DLL not found error.
Aha, because DLL was not found. Again, reinstall your application. That just might fix it. So, all right, now that we've seen that, let's go ahead and rename the DLL back. So we know it's working. We know we're gaining access into the base.dll file. Beautiful. So now we're ready to start doing some stuff?
Right after I clean one thing up. This is initializing it, but it's not necessarily freeing it. Chances are it's probably working out all right because A, it's statically linked, so it goes along with our executable. B, we've given it the handle, so it should know what's going on with our app. But just for the sake of keeping everything clean,
as clean as possible,
make sure we free everything once we're done.
Okay.
And that's another keyword, free. If we look back in the help file, we've got base free. And it frees all resources used by the output device, including any streams, samples, or mod music you've created.
Gotcha. So when we're shutting down, you want to make sure that gets freed.
So as soon as the app, or as soon as this form is getting destroyed, so we can go over to the onDestroy event and simply say base free.
And one more S.
Like so. And compiles, and we're set.
Very nice. Okay. So now we're ready to, play an MP3 file, right?
Yeah, or, load an MP3 file for playing.
Yeah, that's what I mean. So, for starters, let's do it.
Okay. We need some way through the interface of accessing a file, or, I don't know, there's two ways we could go here. We could set it up, do some interface stuff, or we could hard code in a file.
Just hard code in a file for starters.
Okay. Then the first step is to find an MP3 file.
Okay.
If I jump back over to that setup folder and I jump a few levels up, I have a few songs sitting there.
There's a few of my songs which have basically been pulled from my CDs. So let's go ahead and grab those.
Okay.
Or encode it from my CDs, if you will. So you want to go ahead and just copy those into our folder at the moment?
Sure. Just keep these with the...
And no, guys, don't think, that means we have to always put our MP3s in the folder with our MP3 player. That's not the case. Right now, we're just keeping this nice and simple. We're going to show you where you can have them anywhere you want.
Okay. So here are our MP3 files. Now we have to load them into base so that we can play them.
Okay.
The function I'm going to use to load the file is base stream create file.
Okay. So base stream create file. That's a mouthful.
Let's bring the help file back and take a look at what we can do with streams. If we go down to the streams section and expand it, you can see here we have base stream create file. And here it is. This is a function that will allow us to take in a file and return a handle to that file in the form of an hstream.
Okay, and like we were just talking about a few minutes ago, handles being basically just a reference to a system object. In this particular case, we're talking about a reference to the stream, to the video, to that MP3 file.
Right, and the reason we need that is this function is only going to load it. Nothing else is going to happen. It's not going to automatically start playing or anything. So we're going to need to be able to get back to the stream in order to play it or pause it or anything else we're going to do with this file while it's loaded.
Gotcha.
So, to get this set up, what does it look like we'll need? Well, we're going to need some type of variable, because like you were saying before, we store a handle in a variable.
Okay.
So we're going to need a variable to hold our handle.
So a variable that's going to be of type handle.
And, or more specifically, of type hstream.
Yeah.
So we're going to need one of those before we even get this function in place. So let's create that. I'm going to jump back over to Turbo Delphi, and under the var section, I'm going to add a variable called stream, and it will be of type hstream. Now, that's a new type, and that's... will probably seem foreign to everyone because we haven't talked about this kind of type. All we talked about is numbers and strings and stuff.
Where'd that type come from?
Well, I'm going to jump back into that base library for just a second, and if I scroll up to the top, is it near? I'll do a find.
Okay.
And look for
hstream. And there we go.
So this is where it's defined. If you're wondering why this suddenly exists or why it's usable, it's because hstream is defined within the base header file, the base unit.
Gotcha.
So we have a way to store a handle to an open stream. Now we need to do the actual opening part. Now what we're going to do is jump back to the interface for a second. We're going to have an open button in this MP3 player, like a lot of other apps have. Mm-hmm. Now temporarily I'm going to set that up so that it's hard-coded to one file. That way we get directly to the file itself.
Okay.
We can make it a little bit more advanced a little later. So I'm just going to throw a button down, and we can go ahead and name it just to make it a little bit more explicit. And then we can leave the button there for later use. So I'll name it btn open, just to keep things clear. And inside of open, now, we want to have a reference to our stream stored. So I'm going to start off by saying stream is equal to base stream create file. And the first thing it's asking for is mem. That's the first parameter. So let me jump back into the help file and take a look at some of these. Under parameters, it says that if mem is set to true, that we're going to stream the file from memory.
Ooh, set it to false.
Yes, most definitely. We have a file on the hard drive. We looked at those just a second ago, so no, in our case, that is going to be false. Next, we have the file itself. Yeah, now that is useful. File name when memory is equal to false, or the location. So if you were dealing with memory, you could specify it there. In our case, it is false. So we need this to point to a file name.
Okay.
So I can write in, Now I had that setup folder. I'm going to use this one just because the path is shorter. C setup, and then one of these files.
Okay.
So I'll copy one of their names, and I'll put that in here. So we have C setup, and then one of those songs.
It wouldn't see the song if it's the executables in the same folder as...
No, this...
Okay.
Well, it's hard to say. That would get into the way the path works and the current path and
okay,
all
that's
that,
cool.
current directory.
Cool.
The reason I'm putting that is I know that'll work for sure.
Okay.
Plus, this is, again, this is more of just a test. Once we get into the rest of the app,
we're going to be stripped out anyways.
So we have that set up.
Because what fun is it having an MP3 player that always opens the exact same song?
This player is good for exactly one song. All right, that's our file. What else do we have? We have things like offset, length, and flags. The offset is whether or not to begin from the stream, or begin from the beginning, and it's only used if you're working on a file. So we want to start at the beginning, not like some offset into the song.
Exactly.
So I'm going to leave that at 0. So we start at the beginning.
And then the next one you'll see is the length data, length 0 equals, use all data up to the end of the file. So obviously we want to use all the way to the end of the file, so we'll go ahead and set that at 0. Cool.
And finally we have flags, and again, I'm going to leave those 0 because we're not going to specify any flags.
So we want to keep this as simple as possible.
So while all that looks good, if I try to compile this now, we get an error. And that is on the string part. It says incompatible types, pointer, and string.
Ooh, pointer and string.
Now, the way they specified this was what's known in Delphi as a pchar.
Okay.
So it's...
it's a pointer. First of all, you can see if you move your mouse up to where it says void, there we go. It's a pointer to a file, basically. And we haven't got into pointers yet. It gets a little bit more complicated when programming. But basically, a pchar is what we need to use. So we need to cast this. So what we can do is basically cast our string over to a pchar. Now, I know this is going to seem a bit foreign to those of you that are new to the world of programming. I know you're thinking, but you've covered variables. Now, what is all of this? Well, we're converting the variable from one type to another. That's what casting means. I don't want to say what I was just thinking. I'll save that till we get into a lesson on pointers. But just for now, bear with us. That's what we're doing. We have to convert the type, and Logan is doing that right here.
Okay, so let's try to compile again. And there, compiled just fine.
Compiled fine. Good deal.
Now, we need to add a check after this to see if that did indeed load correctly. Because you could have a file that doesn't exist, or a bad file, a bad path, or anything else could go wrong.
Exactly.
So we need to check this before we use it.
Now, does it back over in the help file? Does it tell us?
If we go down to the bottom to the return value, if it's successful, we have a handle. Otherwise, we get a 0. So if we get a 0 back, or if a 0 is held in that stream, that means something failed within stream create.
So we can simply say if stream is equal to 0, then show some sort of message.
Could say something like error, loading file.
Okay. And then... well, there we go. It's really that simple.
So this compiles. We could run it now, but there's not a lot we could do with it. I mean, we could just verify that we don't get an error. And we don't.
Okay, it's loaded. Yeah, now what?
So, well, now we need to use it.
Now we need to play it.
So let's create
another
play button.
Yeah.
So drop another button down. This guy, we'll set his name to BTN play. And the caption will simply be play for the play button. And jump into his code.
And this is actually really simple. Basically, you're going to find several functions inside base, things like base channel play, base channel pause, base channel stop, etc. And in this particular case, all we need to do is say base channel play, and then the really important thing is we're going to need to pass it the stream. As a matter of fact, there's going to be one more thing they're going to need too if you want to. Well, go ahead and start typing it out, and you're going to see when it gives you the pop-up tooltip. So base channel play. And then here we go. First thing, a handle. So remember how just a second ago we got a handle to our stream. So we need to use that. So that's simple enough. It's just stream. Now, restart. True or false? Are we going to restart the file when we hit play or just let it keep playing?
In this case, since we're going to have a pause button, we don't want to have play always restart the file. We want to have the ability to play from a pause state without restarting, so we're going to set this to false.
So that means once it starts playing and we keep hitting play, nothing's going to happen.
Right.
Well, it's going to appear like nothing's going to happen. It'll just keep playing.
So, I guess we can check this out. It compiles, it runs, we'll click open, and we'll click play. And
Logan's waiting to hear if he hears anything through the headphones.
Say we're just checking on audio.
Actually, hand me those. And I hear music.
So, it's working.
Excellent, it's working.
Now, we have no way of stopping this, and if I click the play button over and over again...
And it just keeps on playing. Excellent, good deal.
Now, as we close the app, it will stop playing, and that's, of course, because we're freeing up base at the very end. So,
handling, clearing out the streams.
If it finds any streams, it'll clear those out when it gets hit.
Okay, very simple. All right, so now that we have that in, I guess we can go ahead and take a look at adding a little bit more functionality. First of all, how about getting rid of that hard-coded name? Let's get it to where we can just open up and start playing any file we want.
Okay, so we're going to need something that will allow us to select a file. And one thing that will do just that is an open dialog.
All right, so here is a new kind of control that you guys have yet to play with.
I'm going to jump down to the dialog section in the tool palette. And from there, the first thing is T open dialog. If I drop one of those in place, it's a non-visual control. So if we were to compile and run right now, we don't see anything on the form. Instead, this is just a control that gives functionality that we can tie into.
Okay.
I'm going to change his name to OpenDLG.
OpenDLG song. Okay.
And once we have that, we should be able to go back to our open buttons code and change this out. Now, we need to invoke that open dialog, and that's done by accessing its execute method. Now, execute will return true or false depending on whether or not it worked. Not just whether or not it worked, but whether or not the user opened a file or they canceled it. Because, of course, an open dialog has a cancel button.
Right.
And if we've canceled, we don't have a file to open, so we can't attempt to execute.
Because that would be bad.
So we're going to start out with a check. And that check will hit the open dialog's execute method. And this is kind of interesting because the execute method is like a function. It returns information and it causes something to happen. Kind of like when we were working in the function section, we had a function that both wrote a line out and returned data.
Mm-hmm.
So we're going to say open DLG song.execute. And if this was false, then I'm going to exit out of the procedure entirely.
And this may be a bit of a new... Yeah, this is definitely something new. For those of you out there that are complete beginners and you have gone through our procedures and functions video in number 5, this right here is going to cause execution to end, and we're going to immediately jump out of this procedure and return back to, well, in this particular case, just idle, if you will. So basically, we're going to click the open button, dialog comes up, you hit cancel, then there's nothing else in here that we need to do because, well, you hit cancel. And logically, I know for those of you out there that may be programmers, you may be thinking to yourself, why not just say if open dialog.song.execute and then encompass all this? And that just gets into logic flow, and we'll be doing things like that starting here in the very near future. Right now, we're trying to code this in such a way that a beginner is able to easily, jive along with what we're doing.
Right, just keep it looking as simple as possible, fewer nested things. Okay, so we've got it set up to where we support cancel functionality, where we don't try to open nothing if nothing is set.
Right.
But if this was set to true and we get past that line, that means there is a file to open. So we need to take this file into account when we go to create the stream. So I'm going to scroll over just a little bit and replace this literal string with the data held within that open dialog.
This is really simple, guys.
So within the OpenDLG song, one of its properties is file name. And that's basically a string that holds, or just the string to that file name.
That's right. Now, one more thing you could go ahead and do while you're in here working with the Open Dialog Song control is go ahead and set its filter.
Oh, good point. Because if we look back over here, as a matter of fact, let me run it for just a second.
Sure.
If I can
show them what
it compiles. So it's defaulted to the My Documents folder, which is fine because we're headed towards this MP3 folder anyway.
Mm-hmm.
And from here, we see MP3 files, but we see everything else. We see things like executable files, DL files, everything.
Right.
That's because there's no filter has been set. And it would be good to have a filter in this case because we can only play songs. So with the OpenGLG song control selected, we'll jump down to the, localizable? Yeah, there we've got a filter, which brings up a filter editor. So the name of this filter, we'll call it MP3 Music.
Sounds good.
And the filter will be star.mp3, so only MP3 files.
So click OK. Now let's run it again and watch what happens.
Click Open, and there we go. Only MP3 files are shown.
Very nice, very nice.
And that
so now you can test it out. Go ahead and load, open that up.
And play.
And I'm hearing stuff.
All right, so
now open up another one and show them the new problem we've got.
All right, we've got...
Now listen carefully, guys. Go ahead and play. Surely by now you guys can hear the problem. All right, go ahead and stop that before I go crazy.
So that's interesting. We have two songs playing over each other. And that might seem a little bit confusing right now because we've only defined one stream. So it might seem odd that we're able to load additional files over each other and keep them playing. But you've got to look really carefully at what's going on here. Every time we have a file, we open that file and store a handle to it over in stream. So what would happen in this case if we already had a file? Well, one, the stream would be set. But as soon as we run this, we open a new one, regardless of whether or not there's an old one, and overwrite that value within stream.
Can I go back over here to the whiteboard real quick? And let's clear this out. So basically we have MP3 file right here, MP3 file right here, an MP3 file right here. And we define, here's memory, as we've seen it tonight. And we define our handle, which is pointing to our stream. And visually what's happening is we are setting it when we open up the first file right here to this MP3 file. Then when we come back in here and we do another open at the moment, what's going on is this is gone. Now we're pointing to the new file we just opened. That doesn't mean that this guy just got removed or anything. He keeps playing. That stream's, it's doing its thing. We're just now referencing a new stream. And then we start playing that one. Then when we open another one, this guy continues to play, but now we're referencing yet another one, right, Logan?
Right, that's the idea, that handle only holds a reference to the stream. If we keep creating more or if we overwrite that value, it doesn't do anything to the stream itself.
Right. Exactly. So anyways, that's what I just wanted to show you guys. That's what's taking place there. So it might be a good idea to, stop what we're currently doing and start with a new song or something.
Right, and do a check to see if stream has been set or not.
Yeah.
So right before we create a new one, we can do a check and say that if stream does not equal 0, then we need to free the stream.
So that means, what Logan's saying there is if string is less than or greater than 0. So if it's anything other than 0, then it contains a handle. It's pointing to something. So that means we need to go ahead and free the stream we're currently working with because we're done with it.
So let's see, if we jump over to...
We'll just go ahead and do the base, and then we got stream free and tell it what we're going to free.
And base stream free takes in the handle, which will be stream.
And let's go ahead and just enter that down on the next line. And
just keep with the standard we started. As a matter of fact, I could do that for things like that.
That'll work. So if stream, if there is a stream basically, then let's just go ahead and free it. So now we can go ahead and run this again, and we'll open something up. And it is playing, so next. And play. So much better. So much better. All right, so now that's working exactly the way we wanted it to. Fantastic. Okay, so now that we've got that working out, next thing we need to do is, let's go ahead and move on to a little bit of pause functionality so that we have the ability to pause a song. So if you want, we can go ahead and drop down 2 buttons, pause and stop, because we're going to need to code both these in.
And I'm going to grab all of these and move them over a
little bit. Go ahead and
bit.
make that open into more of a square and put a caret as its caption.
Okay.
There we go. We'll use that as our open.
And that gives us the rest of the room for the rest of the buttons. This one's going to be pause, so I'll jump down to its name, and it will be BTN.
Pause? Yeah. BTN, not P.
And one last button.
Might want to set the caption too.
I was going through it. This way it'll stay on name as I run through.
I got you.
It's kind of like batch workflow. All right, and last, the captions.
Okay.
So there's pause and there's stop. Now pause should be simple enough. We've already seen channel play, so we can use bass, channel, pause, and feed it the handle. And that's all it takes.
Tell what stream we're pausing. Because you guys have already seen, we can have, obviously, multiple streams running. I mean, we could write our logic just a little bit so that we can manage multiple files.
Right, all we'd have to do is have multiple variables that could hold different streams. Each of those variables points to one stream, and then we can have multiple songs playing.
Exactly. Think about it, guys. Come on, start thinking about your game. What if we had some background music, some effects, things like that, and we happen to do them all as MP3 files? I mean, there's obviously other types that's available as well. But now you have the ability to say which particular stream you're working with. So now this could be, let's say, background music, and you're about to pause the background music. Just giving ideas, just examples. So let's go ahead and see if that works real quick. So we'll open one up and pause it. Ooh, okay, I don't hear anything. And play. Hey. Fantastic. Okay, that's working good. So now let's go ahead and get stop in there.
And, as you might be able to guess, we have a bass, channel, stop.
Ooh. And, of course, it's going to take in the stream. Well, the handle, which in our case we're calling stream. Okay, so now we can play that because there's a bit of a problem with this. Let's go ahead and execute. Okay, and opening. All right, so now let's hit stop. All right, very nice. Now let it hit play. It's working. Go ahead and close it. It's working absolutely the same as pause. Usually when you stop something, it also rewinds back to the beginning of the song so that if you were to hit play again, it starts all over. Otherwise, why even have a stop button? Just you have a pause button. So let's go ahead and make that work properly. And what we need to do is reset the song. We need to set its position.
Then that's the key. Set the song's position. We can use bass channel set position in order to do just that. So bass channel set.
And hang on before you even open up. First of all, go ahead and change set. And then before you give the opening paren, let me tell our viewers. Guess, guys. Come on. Just guess. What do you think? Just common sense. You're going to need to tell it what stream you want to set the position to and where at. So it's going to be looking for two things. So open paren and, what do you know? Two things. So set the stream. And we're going to set it to 0. We're rewinding it back to the very beginning. That simple. Let's go ahead and compile it and test it out. And it's playing. Stop. Play. Okay, go ahead and close that. Beautiful. So stop's working perfect. Pause is working perfect. Play is working really good. Okay, this is really starting to speed up, guys. So let's go ahead and quickly throw in a display title so that when we're playing a song, we know what song we're playing. So just throw a T panel up there.
That'll work. That'll give us a nice border. So you throw something.
Yeah, it looks good.
Like that.
And we'll just knock it down, take the caption off. So change its bevel louder to lowered. Yeah, that looks good.
And let's see, we'll name this as well just for
PNL display. Okay.
Now we want to set this as soon as we have a song loaded.
Which means we'll just hit the open area, yeah. Makes the most sense.
So after we've loaded in a file, then we can say PNL display dot caption is equal to whatever that open dialog was set to. So you can do open DLG song. There we go. Dot file name.
And before you write too much further on this, you want to think about the logic for a second, because right now, if stream equals 0, we're going to tell them there's an error loading the file, and then we're going to populate the display with the...
And show them the file that they're not listening to.
Exactly.
So do you want to throw an else in?
Yeah, probably else. Then we can go ahead and do this. So else, and this will be multiple lines, so we want to begin and block it.
That's true. We are going to get into multiple lines, so we can do the blocking.
Okay.
Yeah.
So all he did is just set it up so that if stream is equal to 0, that means we didn't create the file stream. So we're going to give an error saying that there was a problem loading the file. Otherwise, now that means we successfully got a handle back. We're ready to play the file. We've got it loaded. And now we can go ahead and set the caption and all that good stuff.
So if I try to compile, it's not going to be too heavy because of the way else works with terminators.
Got to take that one off.
And
we'll still have an if and else video coming up in the near future.
So now I should be able to see what happens. And
Ooh.
we do want to clean this up a little bit because it's the entire path is...
Yeah, we just want the name of the file. Extract the file name. Oh, what do you know? Extract file name. How simple's that? And we compile, open.
Good.
Very nice. And do another one?
So if we were to reopen a different file,
fantastic.
A different file.
And hit play, just make sure that whatever's open is playing. Beautiful. Okay, good deal. Okay, so now we have that in place. Technically, we've got a very basic MP3 player. We can open up MP3 files, we can play them, pause them, and stop them, and we can see what file it is we're listening to. Now, let's get a little bit more creative. Let's add a track bar.
Yeah, I mean, almost all audio players have that. It's kind of handy.
Yeah, for sure, because maybe I want to jump forward to the middle of it or near the end.
So let's go ahead, or let's set one of those up. To make a track bar, we're going to use a scroll bar. So let me drag one of those out.
And while he's dragging that out, I'll go ahead and let you guys know. There's two different areas that we need to handle here, two different objectives with the track bar. One, it needs to be able to handle manual tracking, which means we, as the user of the application, need to be able to go in there and drag on the track bar to control where in the song we're listening to. The other objective with the track bar is when we let go, it needs to be able to update on its own. So if the song is 50% through, the track bar needs to be 50% through. The track bar needs to update automatically.
Right, because in any other player, as the song's playing, you can just watch the track bar indicate where the song is at.
Now, we are setting this track bar up in the most simplistic way possible for a new programmer. There are fancier approaches to doing this track bar. I just wanted to say that in case you happen to be a more advanced programmer watching this thinking, well, why don't you just use some callback messages and stuff like that? We're going to keep this simple. Just keep that in mind. So, Logan, with that, you want to go ahead and set the size on it so it looks a little bit more like one?
You could do...
Yeah, something there.
I'll just set it to
10.
To 10.
Cool.
All right. The first thing we're going to need to do is to...
We'll do manual tracking first.
Right. In order to do that, though, we need to think about the range that we're going to be tracking to, because that's the first thing to think about. It's like, what does this track in? Does it track in time? Does it track in seconds, minutes, or overall length of the file? In our case, with the simplest way of getting the length of a stream in base is in bytes.
Okay.
So the easiest way to keep us from having to do lots of conversions would simply be to set the range of the slider to the length of the loaded file in bytes. And we can do that, or it would be best to do that at load time. So every time we load a song, we update the track bar to have the correct range. Because, I mean, if we had a song that was really short, and then we load a song that's really long, and all of a sudden we can't short our track to the end of the long song.
Exactly.
We need to keep everything up to date.
There's three different things that we need to do. We could just go ahead and set the minimum to 0, so that'll be our beginning.
And I think that's how it defaults. Let me check.
It should be.
Yeah, there we go. We have our
and
minimum.
Before we go further, go ahead and change the name of that.
I almost forgot about that.
Yeah, just do like SBC track bar. So scroll bar, track bar. Okay. So now let's jump over into code. So just go ahead and put the min in there. So we'll do min, max, and set the position every time you open it.
Okay. So SBC.
I just want them to see that we can code this.
Min is set to 0 because a file is always going to start at 0 at the beginning of the file. Now the max.
Now there is a function that we can use. That's right. What function is it? Well, inside of base, there's a function called base channel get length, and you can provide it with a stream, and it will tell you the length of that stream. So there you go. We just handed the stream our handle. Okay, now there's a problem with this, right, Logan?
That's right, and this will give us a max of the very last byte in the file.
MP3 file, right.
And if we try to track to that very last byte, it won't allow it. It's kind of like going over the last byte. It won't allow you to track to it, which means the visual effect would be that we would track the track bar to the very end, let go of it, and would snap back to wherever it was because it was an invalid seek, and then it'll retrack.
So we can fix this by just simply subtracting 1.
And that'll make it so that if we tell it to go to the last byte, it actually jumps 1 byte before it. And a byte is less than a second, so it's not a bad effect to us. To the user, it'll still look like if you track to the end, the song will instantly end.
Right. Now let's go ahead and add one more thing in there. Let's go ahead and do the SBC trackbar.position. Let's also set that to 0, which right now you guys might be wondering, why do you really need that? At the moment, not so important. Well, yeah, it is. I mean, every time you open a file, especially when we get the automatic synchronization going on between the track bar and the song when the song's playing, you want to make sure when you open a new file that the position of the scroll bar is always at the very beginning. Beginning of song, scroll bar at the beginning.
If you've just opened a song, it can't be anywhere else other than the beginning.
Exactly. So we'll go ahead and set that up here.
So with that, we have our length being set, but we won't be able to see any effect yet because the track bar isn't causing anything to happen.
Exactly.
So
we've just kind of initialized the track bar every time we've opened up a new song.
That's right. Now I'm going to go into the track bar's events and look down at some of the events you have with a scroll bar. You have on change and on scroll. The difference is on change will occur every single time that it moves, whether it's moved by...
So while you're dragging it, or if a timer's making it change.
Or if you let it go.
Yeah.
Now, on scroll will give you different types of scroll events, meaning it can tell the difference of as you're dragging it versus when you let go of it.
Right.
And that's going to become critical here, as you'll see in just a second. Because if we look over, we have scroll code given to us. And that's what we'll use to tell the difference between just being dragged and being let go.
Okay.
So we can use that by saying that if the scroll code... Now, I'm going to jump into scroll code for just a second. Let me actually scroll over a little bit. It's of type T scroll code because we need to know what to check. Is this number-based, or what do we need to check for how to tell the difference between track bar has been let go versus track bar is tracking?
Okay.
So I'm going to hold control, and you see that this underlines. That means I can jump to where that's defined. And that was defined within standard controls. If we look at all the different scroll codes, one of the ones we have is SCN scroll.
Okay.
That's the one that we'll use to let us know that the scroll has ended, or another way to look at it is that we've just let go of the scroll bar.
Yeah, because think about it. When do we want the song to update to the new position of the scroll bar? The moment you let go. Okay.
So if this is an end scroll, that means we have just finished tracking somewhere, and we need to have the position in our song set to wherever we've tracked on the scroll bar.
And Logan just said the key thing there. We need to set the position.
So we'll use base channel set position, and it takes in our stream and where we want to track to, which is going to be the track bar's position.
Excellent.
So we should be able to try this out now.
Agreed. Okay, so now it's track. Excellent. Excellent. All right. So it's working. Fantastic. So now let's go ahead. Now that's the manual tracking. Now let's put the automatic synchronization or automatic tracking in, and then show them the interesting problem that we inherit from doing this.
Now, the way we're going to do automatic tracking will be based on a timer. Since, like you said before, we're not going to get into complex things like callbacks or anything like that. What we're going to do is have a specified interval, check the song, see where it's at, and set a track bar to wherever the song itself is at. So that means we're going to need a timer. Timers are, of course, located under the system category. And the first thing there is T-timer.
So let's go ahead and change its name.
So TM, was it track bar?
Yeah.
And I'll double click it to jump into its event. And what we want to have happen is, like I said just a second ago, we'll look for where the song is currently at and set the track bar's position.
So we'll just simply say SBC track bar dot position. So this time we're not reading it, we're setting it, so colon equals. And then we just need to do base channel get position.
Just like when we were loading a song.
Yep.
Or that was get length.
Yeah, it was, wasn't it? And there we go. So we get the position of where we currently are in the stream, and we assign that to our position. So, does this look good? We have a problem. Let's go ahead and test this real quick. And we'll open up and play a song. Now let's just watch. Ooh, look at that. So what do we see? The track bar is indeed moving. Let it go ahead and move for just a little bit longer. Okay, now go ahead and try to track and just hold it. Up, up.
Can't just hold it.
Up.
Every time the timer hits, it's resetting the track bar back to wherever it was at.
That's right. So we've got a problem. Go ahead and hit stop. So yeah, we can't track because the timer is kind of stealing it away from us and snapping back to where it's currently playing. So we need to somehow disable the automatic timer part when we are dragging and then re-enable it after we've drug the thing and let go.
Right, and to do that, we're going to need to remember whether or not we're holding on to the track bar, because this isn't a check we can do. The only time that we know whether or not we're holding the track bar or have dropped it is in this on-scroll event.
Right.
So that means, based on this, we're going to have to decide if we're holding it or if we've dropped it. And in order to remember something, we're going to need a variable. So I'm going to create a tracking variable. That will be a Boolean. And we'll use that down here. We know that if we've hit the end of the scroll, that we're no longer tracking. After we've dropped the bar, that's the end of the tracking. Now I'm going to start a begin and end block here because we need to do multiple things. So know that here, tracking will be set to false because we've let go of the track bar and we've initiated a track.
Right.
Now, this gets into another logic thing. We could always set tracking based on being in here, or we could do an else after this. I guess just to keep it perfectly clear, we could do it as an else and say tracking is equal to true. And leave that off here. Matter of fact, it needs to be like that. Okay. So that compiles. And again, that's just saying that if we have stopped scrolling, then we've let go of the track bar. Because if we never set tracking to false, then we'll never be able to track.
Right.
So if we've let go, we've stopped tracking. Otherwise, tracking is set to true because we've got some other kind of scroll code, like we would just started or we were in the middle of scrolling.
Now, we need to use that.
So we can do a check inside the timer and say that if tracking is false, then we're allowed to set the position. So if we're not holding the track bar, let the timer set the track bar's position to the song. Okay.
Now, I do want to bring your attention to something for those of you that are still new to the world of programming, and that is scope. Now, here we are. We're kind of starting to mix everything together that we learned in episodes 4 and 5 of the Delphi Training Series. And that is, remember how we demonstrated in episode 5 that variables defined locally can only be seen locally by the procedure or function. Well, here, Logan is demonstrating using a variable that can be seen in this procedure, could also be seen in this procedure, and that is because all the way back up here, that has been defined or declared outside of these procedures. So this is global to this unit.
Yes, throughout this entire unit, those could be considered global variables.
So that means if this guy reads it or changes it, this guy can read the change and vice versa. Okay, I just wanted to point that out real quick.
That's why that variable survives between the two of these. It wasn't local to any one of these, so that means that if one can see it, the other can see it.
Exactly. Okay, so we can check this out now.
So here's our song. And we've got our automatic tracking. You can see it move. Now if I grab it and hold it, I haven't let go yet, so the song shouldn't change yet, but as long as I hold this, it never gets reset until I let go, and then it should track and track the song.
Very good. And it starts tracking again, automatically.
So if we look at it really close, then yes, it goes back to or moving on its own.
All right, beautiful. Now we've got all of the functionality that we set out to add into our basic MP3 player at the beginning of this video. Man, we've been through a lot. So at this point, Logan, I think it's a good time to go ahead and put it in shape for the final look of our MP3 player.
Right, get some of the UI elements, because what we've got so far is more or less just a test or a proof of concept. We've laid down some very simple controls that only roughly resemble an MP3 player.
Right.
The one we showed at the beginning of the video had everything laid out much more nicely. Certain pieces were compressed into smaller areas using icons, and the overall look was a lot nicer and a lot more like a real MP3 player.
Exactly. So we'll give you guys some exact numbers here.
So now we're going to go and reorganize the entire UI into that final look. We're not adding the final functionality yet, of course. We're going to just keep our base functionality with the new look.
Right.
So to keep everything cleanly aligned and separated, I'm going to use panels. So I'll grab the first panel, and this panel, of course, we're going to take the caption out.
Pay very close attention here, because Logan's going to set up a few things that's going to allow for resizing to work properly.
Right, and a few numbers that we have set up ahead of time just to get the look exactly the way we want.
Mm-hmm.
So if you want yours to look the same, then of course you have the video. If you want to be creative with your own, that's cool too. Now the first thing I'm going to do is take this panel and align it to the top.
What does that do?
Aligning to the top makes it to where it will stick to the window and align or stick to the very top of the window.
Okay.
Another way to look at that is that means that the width is always going to be as wide as possible for whatever it's contained in. In this case, it's contained within the form. So as we resize the form, this panel will resize. As a matter of fact, I can show that without even running it.
Very cool.
You can see all of these controls retain their width, and they don't really look at the window to see what size it should be. But as I resize the whole window, this panel now resizes.
Gotcha.
The only parameter left to change is its height, which I will change to 28.
Okay.
And I'll copy and paste that panel. For the second one down, I'm going to set this one's height to 19, and I can copy and paste that again. Oh, and here's one thing to watch out for. You see, as I copied and pasted that, it pasted right under panel 2. So I'm going to drag that back out. As a matter of fact, I can just delete it. I'm going to copy, and then I'm going to select the form before I paste, so that we don't accidentally end up dumping that panel inside the other panel.
Okay.
So here's 3 panels. I'll deal with this one last, and I'll set these 2 up ahead of time. The idea here is, of course, to have the display on the left and then all of our play, stop, and tracking buttons on the right. So the first thing we can do is move this display panel up onto that one. So I'm going to resize it down a little bit, hit Control-X to cut it, select the panel I'd like it to appear on, and hit Control-V to paste it.
And that'll make it a child of that panel.
Now, some numbers I'm going to plug in will be the left, which I'm going to set to 5, and the top looks about right. It looks centered enough. Mm-hmm. Now, the width I'm going to set down to 129, so we have room for some buttons.
Okay.
Now we get into the buttons themselves, and you know what, that still looks a little bit wrong. Let me try setting that to 21. Yeah, that's better. That'll fill more of the panel. Alright, moving on to buttons. I want to use a different type of button than we have here for 2 reasons. One is that we want to use icons on these buttons instead of words, and the second is we want a kind of flattened and then rollover effect. One control that gives just that ability is the T-speed button.
Okay.
I'm going to drop one of those onto the panel, and I'm going to set its height to 21, so we match this guy, and I'm going to leave its width at 23. I'm also going to go under the miscellaneous section and set flat to true. So now I can line that up. Now I'm going to need to nudge these around to get accurate placement, because you can see the snapping is snapping to the top or the bottom. I kind of want it centered, so I'll use Control and the arrow keys to nudge it. So I'll move it up a few pixels until it lines up with the display itself. So that'll be one button. Now we need to add a few more. We need things like pause and stop. We're going to add in a previous and next song button, even though they're not tied in yet. And then finally we're going to have the open on the far right. So this is the look I'm going for. And this, I want this carried on to the other buttons. So instead of creating new buttons, I'm just going to copy this one. So paste the second one in, and then I'll use nudging to line it back up. And I'm looking really closely at these borders in here, and I'm going one. You can see how they overlap, and all we have is the white pixel. I'm going to move it 1 pixel off of that, so we have a little bit of an indentation between them. And paste again for the stop button. Same type thing, just nudge it into place until it looks right. Now we need the tracking buttons, which will be spaced off just a little bit. Maybe a little bit more than that. And that's the previous song button. This will be the next song button. And then we need the open button. And it'll go all the way over on the other side. And let's see. This is looking a little bit wider than it should be. Let me check something. And I'm probably going to end up lowering the width to match our example MP3 player. So I'll lower that down to 307.
Okay.
And move that over to the side. I'll have to move it using nudging. Something right about like that. Now we had a little graphical divider between the transport controls and the open button. The control I'm going to use for that is a bevel, found up under the additional category. So I'm going to drag a bevel into place. Now it defaults to being kind of a box, and all I want is a vertical spacer. So I'm going to go to its miscellaneous category and change the style out to, the shape, not the style. I'm going to change the shape to a left line. And that gives us kind of just a straight horizontal or vertical divider. Horizontal, whatever. Alright, so we have that set up, and I think that looks alright.
Okay.
Maybe one more pixel. Yeah, that's good. Now there's the buttons laid out, and I've held off on naming them or adding icons just because that's going to differ per button. I used the copy and paste to copy everything that was going to be the same between all of them.
Mm-hmm.
So now we're going all the way back to the play button. I'm going to jump down to the miscellaneous section so I can set its name. So it'll be BTN Play.
And we got the one that's down there, so we need to go ahead and...
We can go to all, and now if we try to name these, of course all of these are already named, so I'm going to go into all of them and erase them. Delete each control out.
Okay.
That frees up that name so I can use it with this button. So BTN Play. There we go. Now we can use the name. And let's see. We'll set the name and we'll set we need to set the icon now. The icon is under the glyph property. Alright, so we need to load in the actual image that's going to be used for the icon. So we can go to load, and we have these icons here. We'll include these with the high-res copy of this
Yeah, they'll be in the RAR file. Now, they're bitmaps. What size are they?
They are 20 by 16.
Okay, 20 by 16. So anybody could have made these in Photoshop.
As a matter of fact, I think some of them vary.
Oh, really? So 17 by 16.
They're not standard icon files.
Gotcha.
So we'll go in here and add, let's see, this was the play button, and there's our play icon. So we'll tell it to open.
Now, these are just regular files we made in Photoshop for the most part, right?
Right, just simple bitmap files. If I remember correctly, they're 256 color bitmap files.
Gotcha.
And you can see they have this weird olive color. This will play into Delphi's automatic transparency handling for bitmaps. It'll recognize what colors are on the outside and set that up as your transparent color. So you see as soon as we hit OK, instead of being olive colored, that's now transparent.
Perfect.
So there's our play button. And we can move on down the line from here. We have things like the pause button. So this will be BTN pause. And its glyph will be the pause icon. From here we have BTN stop. And its glyph, of course, stop. These two are the previous and next song buttons. So this one will be BTN previous, and its glyph will be the track left icon, which I've named previous there. We got BTN next, and we've got a next icon. And finally, we've got BTN open and an open icon. So there's all the icons laid in. Now, if we compile and run it, even though we have the same names on these buttons, we've lost the functionality. Now, if we look in the code, we haven't lost the procedures. We still have things like there's BTN play, BTN stop, there's BTN play and pause, so the functionality is still there.
It's just not linked up.
Right, because these are brand new buttons. Even though they're named the same, they haven't been associated with those events. If we go to the Events tab, we can go to where we would normally double-click to jump into this event, but if we hit the drop-down, instead of double-clicking, it will go through and look for all the procedures that would be applicable for this event type.
Very nice.
And there we can see all of our pre-existing procedures. This was the play button, so we can drop play click into place. And now, well, let me do open, because play's not going to do anything without open. So open click, run, and now open has been linked up to the procedure that we had already there.
Very nice.
So we've got open, we've got play. We need to go and set pause and stop. And again, the next song tracking gets into a different episode entirely. So that should have this top portion complete. Now we need to go and set up this bar, which is going to be the tracking and volume panel. So we've already got a track bar. I can simply hit Control-X, select the panel I want it on, and paste it in. Move it over a little bit and center it up vertically, something like that. I'm going to shorten this up a little bit. As a matter of fact, I'm just going to plug a number into that to keep the look we've got, or that we had before. Now we need another track bar. And to, more easily keep the look, I'm just going to copy and paste this one and lower its width down to about 94 pixels wide. And I'm going to move it as close as I can with snapping and then hold Control to nudge it into place. So I'm going to align it to the right edge of this button so we keep up that line on that side.
Okay, and we need to go ahead and set a name for that.
This will be SBC volume. Alright, that takes care of the second panel. Oh yeah, one last thing before I forget. We copied this over, so it's probably still going to have that event set. Mm-hmm. This is going to be a volume bar, not a track bar. So I can simply select this, press delete, and that will clear that out. So we don't accidentally have this working as a track bar instead.
Okay.
So that's that panel. Now I'm going to go and focus on this last panel, which, if I remember correctly, I can probably just go in and set it to, change its align type, and set it to align client instead, and this will make it fill the full client area of the form.
Just out of curiosity, were we going to do the bottom bar on this one?
The bottom bar is laid on top of this panel.
Oh, okay. Okay, I'm with you.
Let me drag these back into view a little bit. And I think there's one other number I need in order to match this up to our example player, and that's to set the height. So I'm going to go into the client height and set that to 352. And there we've got the height of the original player.
Okay.
Now, the next control we're going to need is the box that we use as a playlist. The control for that is AT list box. So I'll drag one of those out, and I'll line it up. So there we've got the left set to 5. I'm going to nudge it up just a little bit to take some of that space away from the top. And then align it out. I'm going to align it. You can see the blue line forming so that I'm aligning to that open button and volume slider. And the height I'll set to something about 269. I can do a fine adjustment on it in just a minute. So that's the playlist. We're not going to get any more advanced into this guy because we're not implementing him just yet. So that leaves the bottom bar that had things like adding and removing from the list, selecting a play order, and so on. The first thing of that, of course, is going to be the add button. So that's going to be a speed button. I'll jump down to additional again, grab T speed button, and add one. And drag it over a little bit and start setting some of its properties. First, I want it to be flat, just like all the others, because these are going to be the same kind of icon style button. I'm going to nudge it up just a pixel or two, and I think that'll do it for that button. So I'll copy it and paste it and do some nudge alignments, just like the others. Now we need a drop down that will allow us to select what type of play ordering we want, if we want to repeat or shuffle or repeat a single song. That control is going to be a T combo box. So I'll drop one of those into place, line it up, and I need to set one more property on each of these. I need to set their height. So I want 21. Reason being is that now I can align it to the combo box. So we've got that set. I'm going to move it over, nudge it over a little bit, because I want enough room to make another bevel, so that we can have another nice little dividing line between these two. So grab a bevel, height of about 17. A shape will be a left line, and then I can nudge it into place. Something right about like that will work. Alright. Now, I'm going to set the width of this down to, I don't know, about, let me see if 67, that's a little bit too low, maybe 102. Yeah, that looks better. So, let me run it to show, we need to change the behavior of this a little bit. If I were to run right now, you can see that we have the ability to type in that, as well as select, and that won't work for us. We don't want to be able to type a selection type, we just want to be given a predefined list of things that can be selected. So we can go to its miscellaneous section, and we can change its style. Change the style to a drop-down list. You see that immediately clears out the area that we can type in. We can no longer type in it, we can only use it for selections. And while we're in here, we can set, might as well just go ahead and set the items, because right now it's blank, we need to have something in there to select. So the ordering items will be things like repeat, let's see, repeat playlist, shuffle playlist, and repeat song.
Okay.
And then I'll go ahead and name it so that we have this control completely wrapped up. Change its name to CB order.
Okay, go ahead and compile and run it real quick.
And
instead of it starting out blank.
Yeah, the problem here is we have a property that lets us select items, and that's called the item index. -1 represents nothing selected. We wanted to have the first item selected, but this is a zero-based list, so we'll set that to 0.
Perfect.
And you can see already that it's thrown in the first item. So, that has that taken care of. Now we need to add the buttons to the right of that, which are the load and save playlist buttons. I'll start with one of these because they already have the look that I want. I'll copy, I'll paste, and then it's back to nudging for alignment. And paste again. Nudge to align. We have those set up. And the last control will be that frequency slider. Now I'm going to copy this, paste it, and it's going to appear way at the top, which is okay because we can just drag it down, lower its width to something like that, and then nudge it to where it aligns on the outside like that, and roughly center it, and then drag it one over, something like that.
Okay.
And since he only has one thing left, I'll go ahead and finish this and just call it SBC frequency, or freak for short.
Okay.
And now I believe the only remaining thing is the names and icons of the buttons. So jumping all the way back over to the add button, this will simply be called BTN add, and we'll set its icon. So we'll go up to the glyph property, and we'll load in the add button icon. And one over from that is going to be remove from playlist. So we'll say BTN remove, and I'm going to capitalize that. And set its icon to remove. So these buttons, this one starting over here with the playlist open. So this will be BTN PL open. And we need to grab our PL open icon. And our playlist playlist save. That's right. I was thinking remove, no. Close, no. Save. So BTN PL save. And our icon here is simply PL save. So yeah, I think, let me save this out, compile this. I believe that's it.
And my question is, what kind of functionality do we have when you resize that?
Oh, good point. Yeah, I hadn't gotten to that yet. So if we were, so this looks right now. It looks like the MP3 player. What if we resize it? All right, we're kind of losing a bunch of controls. Everything's just staying stuck to the side. Same for vertical. As we resize this, the MP3 player stays stuck to this side, and a bunch of free space opens up on the sides.
Right.
So let's look at what we can do with different anchors to fix that. Let's start with something simple. Let's start with this lone volume bar over here. As a matter of fact, we'll start with both the volume bars.
Okay.
This guy, the way I want this set up is to where this guy stays the same width at all times, but sticks to the right of the form.
Okay.
And let's take a look at the anchor properties.
Another new property for you guys.
Yeah. Under the layout section, we've got we have anchors. And under anchors, we have the ways that we can anchor it. Right now it's anchored to the left and to the top. So that means if the left changes, it will change. If the top changes, that will change. Now, those never change because his reference to that side can't change. You can only resize in width, so that means the outer part and the lower part are going to change. That's why you don't see him changing as we resize the form around.
Exactly.
So we can change it so that right is set to true, so it's anchored to the right, set left to false, so that it's not anchored to the left at all. If we run now, we can see that as we resize, he now sticks to the right side of the form at all times.
Nice.
So at this point, it would be cool if we could have this bar fill the remaining area. So if we go over to his anchors, we can set right to true, because we want him to be affected by the right side of the form, and I'm going to leave left true. So we'll see what happens when we have it anchored to the left and right.
Yeah, now he's being stretched.
And that's exactly what's going to happen now. Because he's anchored to both sides, he'll stretch to fill the remaining width.
Nice.
So let's see, what else would be good to set? Well, we could take all of these buttons now and have them stick to the right side just like this track bar, and then have this display fill the remaining area.
Okay.
So I'll grab and shift select all of the buttons and set their anchor right, or AK right property to true, and their AK left to false.
Do you need to do it with the bevel too?
And yes, I will. I would have probably completely forgotten that.
That's all good. That's what I'm here for.
So let's test what we've got so far, and yes, they do indeed follow.
Very nice.
So we can grab the display, set his AK right to true, and now we have the entire thing tracking. So now we have the playlist and playlist controls. The playlist at first seems simple enough. Well, just like anything else that filled size, let's try leaving left to true. My bad, not changing it to false. So just setting right to true. What does that look like? Well, horizontally, it works just fine. Vertically, it's still being left where it's at. So that means we need to change bottom to true as well. So it's anchored in all four directions.
It
hasn't changed yet.
There we go.
I clicked too slow or too fast. I'm not sure which. But now if we track it, it does continue to fill the area. The problem is the bottom controls are left alone.
Right.
So that means each of these should be anchored to the bottom
and go ahead and
not the top.
Grab the bevel too.
Oh, yeah.
Okay.
So we can say that they are anchored to the bottom and are not anchored to the top. So now when we resize this, they keep up with that. The only thing left to do is to fill this area, and I'm going to fill it with the frequency slider.
Perfect.
So frequency slider, let me deselect all of these, and set its anchor to right to true. And there we go.
Ah, beautiful.
So now the UI will stretch appropriately to fill the entire area of the form.
Now we can go ahead and change the form caption to something like MP3 player.
Alright, so we'll grab Form 1, change its caption to Simple P3 Player.
Alright. So let's go ahead and run it. And let's go ahead and open up a song and play. Very nice. Now let's go ahead and move the our track bar. And again. Now let it keep playing and open up a new song. And let's play.
Oh yeah, let's play first.
Which is right in the middle. Beautiful.
So that's right, because I tracked before I played.
Yep.
So we've still got functions like pause. We can pause. We can resume playing. We can stop, and it resets it.
Beautiful. So,
and of course we've seen open, and nothing else is set because we haven't set any functionality for any of these.
Exactly. So we've still got a little ways to go till we have everything in place. But wow, man, we've come a long ways. This has been a 2-hour plus VTM, and I think we have set out to accomplish a bunch of tasks, and we have accomplished them. The objectives at the very beginning was to create a very simple MP3 player, and behold, a simple MP3 player. Excellent. The next thing was to become familiar with what external libraries, DLLs, were, as far as the way they pertain to the Win32 world. We looked at what DLLs are, why we'd want to use DLLs. We even wrote a simple DLL ourselves and wrote our own little simple application that accessed the DLL. From there, we talked about the bass sound engine. We showed you where you could get it from, what all abilities it gave you. We talked about its licensing and everything. And then we got it set up. And then from there, we started writing some very simple stuff that would handle our MP3 streams. And we even talked about handles. And with that, we wrapped up by completing the full GUI for our more advanced, simple MP3 player. And that is everything we wanted to do in this video because we knew that it was going to go on for quite a while, and it has done just that. So, Logan, is there anything else you would like to add?
No, I think that wraps it up. It's been quite a journey. We've gone from learning how to get functionality from somewhere else in the form of DLL all the way into bringing that into a real library base and finally bringing that into our own MP3 player applications. I mean, yeah. Quite a journey.
So the next set of videos will continue with this until we have all of the features in place. So thanks a lot for joining us, and that will wrap this VTM up. Thanks, guys.